This problem, find number of items which are repeated in a collection. I told you we had to use some logic. The logic which we used earlier, it is not suitable. So I'll take this. So this will not give you the correct result. So what we can do is, I'll take this list and I'll take a set of this, or I can directly say for I, I'll take a count equals to 0. Then for I in set of L1 means I want to take the items in the form of a set. I don't want to take the duplicate items. So when I convert into set, I'll get 10, 20, 30, 40, 50, 25, 5, I'll get it. It is not duplicate items. I don't want to store. So what I'll do is then check how many times each item is occurring. So I'll take for item in set of this. So I can take if L1 dot count, L1 dot count. So I'll take this is okay, let it be count, or I'll take this as which are repeated, number of items which are repeated. I want which are not repeated. So first I'll go with which are not repeated. So I'll take unique item. So I'll say UNQ, unique count. And the number of times an item is occurring. So the item from where we are getting from this set. So if L1 count equals to 1, then what I'll do is I'll increment the count. So UNK count plus equals to 1. So now this UNK count will give me the result. UNQ count will give me the number of items which are not repeated, means unique items. So I'll explain the logic. Let me execute first, then we'll see the logic again. So it is giving 5. So 5 items are unique. Like if I take 10 is unique, it is occurring only one time. 20 is not unique. 30 is not unique. 40 is unique, so 2. 50 is unique, 3. 25 is unique, 4. 5 is unique, 5. So this is a number of unique items. So what I'm doing here is I'll do this step by step. This is the program. So I'll take this program. I'll do it step by step so that you can understand. From this L1, I'm creating S1. So S1, what I do is set L1. So why I'm doing this is I don't want to repeat for several times for to count. Like suppose if I say print L1 and print S1, so it will give all items with eliminating if it is repeated several times. Like so here, if I take 10 is in list, 10 is not repeated, 20 is repeated. But when I take it as a set, I'm getting the items without repetition. Now what I'll do is for 5, I'll take 5 and check how many times it is appearing here. 40, how many times it is appearing in the list. 10, how many times it is appearing. So that's what the logic I'm going to do it. So I'm taking this. So I'm not keeping set separately, but just I'm directly executing. I need not have set. So the explanation what I can write here is take this data also. So what I'm doing here is from this set. So from set, this is the set I'm getting. So this is the set I'm getting. From this statement, I'll get this set. I'm taking each item. So 5. So 5 in L1, how many times this 5 is occurring? Now item is 5. How many times item is occurring in L1? So in this L1, this is L1. It is occurring only one time. 5 is occurring one time. Now, instead of taking set, if I take the list, I'll be finding count of 10 once, count of 20 once, then count of 20 again, count of 30 once, count of 30 again, count of 30 again. To avoid repetition, so what I'm doing is I'm taking set. I'm taking now the set without any duplicates. So 5, how many times it is occurring? It is occurring 1. So when it is occurring 1, it is an unique item. So I'm finding the number of unique items. So it is number of unique items I want to find. Initially, I'm making it 0. Initially, the value is 0. Now, when I take 5, the count here is 1 because it is occurring only once. Now, the unique count becomes 1. Now, 40, next item I'm taking. 40, how many times it is occurring here? It is occurring again 1. It is also occurring 1. 40 is occurring one time. So now the unique item count is increased. Next, I'm taking 10. So how many times 10 is occurring here? Again, it is 1. So unique count is incremented. Now 50, how many times it is occurring? So again, it is 1. So unit count is 4. Then 20, how many times it is occurring? It is occurring 1, 2 times. So this is not true, not true. So the count remains 4 only. So 20 is not counted. 25, it is counted. So it is 5. 30, it is not counted because it is occurring more than one time. So the number of items which are not repeated are 5 here. Number of items which are uniquely present in the list are 5. So this is the logic we have to write. You will not get directly. So this is the logic we have to write to find the number of items which are unique. So same thing, suppose if I want to find number of not repeated means unique items, not repeated, here unique. So this, I'm getting this. Now same thing I want, if I want repeated items. So what change I have to make? Now I want items which are repeated. Which are repeated in the collection. So the same logic I can take, only difference is instead of count equals to 1, I have to find count which is greater than 1. Means greater than 1 means it is repeated more than one time. So here instead of unique count, I'll say repeated count. Now I'll take set here. Now count, I'm not using equals to greater than 1. Means if it is greater than 1 means it is repeated. So that I'll get rep and rep count. I'll exclude this. So I'll get here 2. So I'm getting 2. So this you can get once you get this answer, once you get repeated or not repeated, instead of writing again this logic, the other way how we can get is we can say print the length of the set, whatever is there in the set, which is collection of all items without repetition, then number of unique. So we'll get number of repeated count. So this way also we can get instead of once I get the first answer, second answer I can get it easily. Or once I get this, I can get the once I get repeated count, I can get unique count. Once I get unique count, I can get repeated count. But the logic for unique count is the count should be 0, 1. The logic for repeated count is the count should be greater than 1. So that is how we solve the problem. Next, I'll take one more question. I'll take the question. So this is the question. The question is related with some password. So what it is saying is a website requires the users to input username and password to register. Write a program to check the validity of password input by users. So it has to check whether the password entered by user is valid or not. So what is the criteria for validation is the password should contain at least one lowercase letter. Password should contain at least one digit. Password should contain at least one uppercase letter. Password should contain one of these three characters, $, hash, @ and minimum length should be 6, maximum length should be 12. So that is the logic. So if it is satisfying all, then we have to display the password. Otherwise, we should not display the password. So this is the question. To solve this question, we require one string module. String module methods we have already seen. I'll take a module called string. So I'll say string. Why I'm taking this is it allows you to get the uppercase letters so that I can easily write the logic. So ASCII lowercase. I'll get lowercase letters. So all lowercase letters. So first I have to import this. Then if I execute this, I'll get all lowercase letters. Similarly, I can get all uppercase letters. Now to ensure whether the characters that are there in password are uppercase or lowercase, that's why I want to use this already available data in Python in the form of string module. Next, I'll take if I want to check whether it is digits, there is a digits present. Then there is one more, I think, print. I'll take punctuation, which is so these are the different things present. So digits, ASCII, sorry, not ASCII digits, it is simply digits. Similarly, punctuation, it is not ASCII punctuation, only punctuation. So these are the different data sets we require to solve our problem easily. So what it is giving lowercase letters, it is giving uppercase letters, it is giving digits, and it is giving all special characters other than whatever character present on the keyboard, like there is exclamation, double quotes, hash, $, whatever character present on the keyboard, which is not alphabet or not digit, is called as special character. So all special characters all special characters will be part of this punctuation. Now the question here is, when you take the question, the password should contain lowercase letters, password should contain digits, password should contain uppercase letters, and password must contain one of this. And also it means that other than $hash at the rate, the password should not contain any other special characters. Like double quotes cannot be part of the password, asterisks cannot be part of the password. So if I take this sample input given, now if I take this asterisk, it is not allowed because only $hash at the rate are allowed in special characters. Remaining special characters are not allowed. So the logic what I'm going to write here is, I'll take the password. So first I'll read the password. I'll read single password, but it asks us to read a set of sequence of comma separated passwords. But to start with, I'll read simply one password. I'll say input. So the password is entered. Now, suppose if the password here, what logic I'm going to use, I'll explain. Now, if password is suppose A, B, C, 1, 2, 3 hash, suppose A, B. Suppose if this is the password. Now, to take this password, so what I'll do is, I'll take this password. I'll take this password and I'll take the lowercase letters. Lowercase letters are available. Lowercase letters are available in the form of this one, string lowercase. Now I'll take password. I'll take set of password. So when I take set of passwords, I'll get individual characters of the password as set. Why I'm taking set? To avoid duplicates. So I'll get A as one entry, one data item, B as another data item, C and so on. So that you can observe. So I'll write, I'll print the password. And what happens when I apply set on that? That also I'll say print set of password, or I'll take, print set of password. Then what is happening there? You will know. So I'll exclude this. So I'm entering some password like A, B, C, 1, 2, 3, $9, A, B. Suppose if I take this. So I'm getting that password data as individual characters in the form of a set. So password, when I convert into set, all these characters, order does not matter. So order is not maintained because it is a set, but that password data is available this way. And I'll also take the lowercase letter in the form of a set. So what I'll do is I'll say string dot ASCII lowercase. So I'll take, suppose I'll take A, B, C, 1, 2, 3, suppose A, B. Now this is the password I entered, and the password I'm getting as a set, and lowercase alphabets I'm getting as a set. So now what happens here? Now what happens here is I'll take this set of password. I'll take this set of password, which is nothing but this, and set of lowercase alphabets, set of password and set of lowercase alphabets, which is available there. Now I want to check whether this password has lowercase alphabets or not. What I'll do is I'll perform a set operation, which is intersection. So if there is at least one lowercase alphabet present, this will give some value, some set which is not empty, So if I continue further, if I take this program, I'll take this data and enter it again instead of each time repeating it. So what I'll do is now I'll check this. So what I'll do is I'll print set of password and I'll find intersection with the help of and set of lowercase letters, string underscore ASCII lowercase. In dot ASCII lowercase. So I'll take ASCII lowercase. Then if there are some characters present in the set, then one more bracket is it required? Values. Set of password, set of string lowercase, print. What it is saying? Print. Okay, I'll do space. Something here, okay, bracket here it is missing. Now it's okay. Now I'll give this. So it is giving that B, C, A are lowercase letters. Suppose if so, it is giving some data when it is present. When lowercase letters are present, it will get some data. Suppose if the lowercase letters are not present, I'll get empty. Suppose I'll remove lowercase letters, I'll get empty. So if it is empty, I can consider it as, see, I'm getting empty set. If it is empty, I can consider it as false. If it is not empty, I can consider it as true. So now what I'll do is I'll apply this for all other like uppercase, lowercase, digits also I'll do it. So I'll do the same thing with uppercase, I'll do the same thing. And I'll do the same thing with lowercase. Sorry, digits also I'll do the same thing. Everywhere there should be something, some data present, otherwise it is not allowed. Then also I'll do one more thing, which is where we require some special characters. So that special character set I'll take because we don't require all special characters. We require only hash, dollar. What are the other things? We'll check in the question. So what are the hash, dollar, and at the rate? These are the characters present. I'll check whether it is present or not. So I'll exclude this. Now I'll give the data. So A, B, C, A, B, C. Then at the dollar, at the rate, I'll give 1, 2, 3. Now what it gives is, it says, I'll remove this thing, first two to avoid confusion. So I'll will not print this. I'll not print this because there will be too many. So I'll take this data and enter it again. If I say this, if I exclude this now. So first it is checking lowercase. So there are some lowercase letters present. Second, it is checking with uppercase. So it says there are uppercase present, digits present, then special characters present. Suppose in the entry, suppose if I don't give one of them. Suppose if I don't give digits, now lowercase are present, digits uppercase are present, digits are not present. Digit is not present, I should not consider that as a valid password. But the special characters are present. These are the things I have to check. So if everything is there, then I had to consider it as a valid password. So I'll go again. I'll write a slightly different way. I have written individually there. Now what I'll do is I'll combine them into one statement. So I'll check if set of this, if this is true, this is not empty, and is also not empty, means lowercase characters are not empty, uppercase characters are not empty. Then I'll go ahead with the next one. So here, because it is more than the length of the line is more, if I want to continue, I can use backslash there. So I'm using backslash. Then I want to check whether digits are present or not. This is one more condition. So I had to use and here, and whether digits are present or not. Finally, and whether special characters are present or not. So if everything is present, then I'll say it's a valid password. So here I'll say print password is valid. Otherwise, I'll say it is invalid. Else, I'll say I'll take I'll say it is invalid. Now I'll check first this, then we'll check the remaining part is not valid or invalid. So I'll execute this. So somewhere set password, what it is saying. I think one more bracket is required. So think that, and I'll take bracket here. So let's put this. So it is saying invalid syntax. Somewhere where it is saying invalid syntax. So okay, here I should not give space. I think now it should be okay. This can be. I'll give space here. Think extra bracket is there. Okay, understood. So there is extra bracket here. I will come down. Here there is extra bracket. Here also there is extra bracket. Because I was using for printing, now I think it should be okay. I'll execute it again. Now it's okay. I'll give the data. So I'll give. So A, B, C, A, B, C. Only one I'll take. 1, 2, 3 hash I'll take. Now it says it is valid because everything is there. Now I'll execute it again. I'll not give lowercase letters. So I'll give A, B, C, D, 1, 2, 3, then dollar hash I'll give. Now it says it is invalid because there is no lowercase. So similarly, if I don't give digit, it says invalid. So I can, it will check individual thing, individually whether each one is present or not. So if I say capital small a, capital A, B, C, D, dollar hash, I'm not giving the digit, so it says invalid. So this is the logic I'm checking whether password has some lowercase letters, whether password has some uppercase letters, password has lower digits, and password has this three. So this is one step, but it is not complete. Why? Because the one more condition is here. It should contain only this, but suppose if it contains some other character, some other special character, it should not, it should say invalid, but this says valid. So suppose if I take dollar at the rate, I have 1, 2, 3. Now asterisk I'm keeping. Now it says valid. So it is valid, but it is wrong because there should not be when the question says at least one character dollar hash at the rate, it means no other special character should be present. So I should also consider whether any special character is present. If any other special character is not present, then I should say valid. Otherwise, I should say invalid. So what I'll do is I'll extend this. I'll check set password. So I'm checking whether password is having some character which is special character. Special characters, how do I get? String dot punctuation. But some special characters are allowed. The characters which are allowed, I'll exclude. So that I'll exclude, like by saying minus, I can exclude that. So I'll say hash dollar at the rate. So now what it does is it will check whether I'll take a bracket here. It will check whether any special character other than this is present. Any special character other than this is present. If any other special character other than this is not present, here we don't require. So I have to say not. Now I'll take this. Now it says it is invalid. I'll execute this. When I execute this, sorry, spelling mistake there. Punctuation, spelling mistake have written. So so punctuation, this is the spelling. So I'll execute this again. I'll take this. Now it says not valid. So why it is not valid? Because there is asterisk present. Even if I take any other special character, it should not allow. Now if asterisk, if I remove, it will say it's correct. So I'll take this and I'll remove asterisk. Now it says it is correct. So it is valid. So I should not have any special character. I should not have any special character other than this three. So that is one thing. not only that, what is the question? There should not, the length of the even space should not be allowed. When I take space, space is also a special character. It should not be allowed. So one more thing here is the length should be in between 6 and 12. Length should be in between 6 and 12. So I'll also add that condition. So what I'll do is I'll add one more condition. The condition is length of password is in between 6 and 12. So I'll take one more bracket. 6 less than, this way we can write it less than or equals to password. Then this is less than or equals to 12. So this is also I'll include. So I'm including whether password is greater than 6, greater than or equals to 6, or less than or equals to 12. Now I'll execute this. I'll give the same thing with I'm keeping asterisk, so it says invalid. Then I'll execute it again. I'll execute it again. This time I'll keep every character, but length I'll so uppercase letter I'll keep, lowercase letter I'll keep, digit I'll keep, then hash I'll keep. But length is not 6 now. Length is not 6. It is saying lowercase is there, uppercase is there, digit is there, one of the special character is there, but it is invalid because length is less than 6. So it says not valid because of length. Now I'll take everything again, execute it again. I'll execute it again. It's not this one. So I'll execute this again. So I'm keeping ABC 6. I'm keeping everything 10 characters. I'll add one more DEF. Now I'm keeping 13 characters, but lowercase characters are there, uppercase characters are there, special characters are there, digit also there, but the length is greater than 12. So now also it says invalid. Now also it says invalid. So it says invalid. So this is it's still, it has one small problem. I'll execute this. Now when I give, suppose A, B, C space, if I give capital A, B, then dollar hash, I'm giving 1, 2. Now it says it is valid, but space should not be allowed. So it is valid. So space is not part of punctuation. Space is represented with white space. So I'll say set whether password has. So there should not be any white space. So what I'll do is I'll mix this with this. I'll also combine this. So I'm not only subtracting special characters, I'll combine union with the white space. So I'll say string dot white space. So there is white space. Then I'm combining with white space by using the symbol pipe. So I'm subtracting 3 special characters. I'm combining white space. Now, if I take this and give this, it says invalid because space is there. Space should not be there, but it is there. So it says invalid. Now I'll execute it again. So I'll give this. Now it says is not valid. So this is the logic to find whether a password is valid or not. So this is the full logic. So it is checking whether lowercase is there. So this part checks whether the length is valid or not, whether it is within 6 or 12 or not. This part checks whether lowercase is there or not. This part checks whether uppercase is there or not. This part checks whether digits are there or not. Then this part checks this three special characters. One of these three special characters are there or not. And this part checks whether any other special character or white space is not present. Then only it is valid. Otherwise, it is invalid. So this is the logic of the password. So this I'm using set operations. That's why I gave this program here. I'm also using string module where some constants I'm using like uppercase, lowercase. So digits, they're available as data. So I can straight away use them instead of building the data, because the data is available in the form of a library module. I'm using it. So that is the password program. We'll go ahead with we'll write some more programs and set lists and tuples. But first, I wanted to complete the next concept, which is dictionary. So we'll start dictionary. So when I take list, tuple, set, even string, they're all kind of collections. Now, when I take dictionary, is a different kind of collection. These are collection of items, single collection of individual items. But when I take dictionary, collection of key value pairs. Key value pairs. It is collection of key value pairs. Why it is called as dictionary is based on key, we can search for this value. Like dictionary, based on some characters, we can search for some word. So characters which we search is actually key, and the value is the one which we get. For example, suppose another kind here is, I'll take 1. I want square of 1, 2 square of 2, 3 square of 3. I want to square of all the numbers. So 1 is key here. Now this is value. So I'll search, I want square of 1, I'll get it as a value. I want square of 2, I'll get it as a value. So this is key value pair. Similarly, when I I can take state name AP capital as key. So this is key, the capital as value. So always this kind of data, if you want to represent, then suppose I can take the other TN like Chennai. So this is another kind of key value pairs. So you can have a different key value pairs based on your requirement, and I can maintain. We can maintain in the form of a dictionary. Later, we can easily when key is given, you can get the value. That's how normally we use dictionary. So dictionary maintains key value pair. Why do we maintain is whenever I have a key, I can get the corresponding value. So here in the key value pair, the key must be unique. You cannot have any duplicate values, but the value can be duplicated. So it is not necessary that value must be unique. It not necessarily unique. Not necessarily unique. So this is one important thing. So dictionary is key value pair. You can use any kind of key value pair based on your requirement, and key is unique and value need not be unique. Generally, when key is given, we'll search for a value in the dictionary and get the value. So that is the purpose. And in Python, dictionary we created with flower brackets, and key within this we keep key value pair. So how do we keep key value pairs is take flower bracket key 1 value 1, then comma key 2 value 2. So the key value pair we separate with the help of colon, and the entire set of key value pairs we keep within the flower brackets. So this is how we create it. So I'll take this, we'll take some dictionary here. So I'll take first simple dictionary. So D squares, dictionary of squares. So I'll take flower brackets. So 1 square of 1 is 1. Then 2 square of 2 is 4. 3 square of 3 is 9. 4 square of 4 is 16. I'll write 1. 5 square of 5 is 25. So this is key value pair I'm creating. I'll create. Now, when I print this, I'll just get this weight. So I'll print this and also the type of the dictionary. So I'll say type of D square. What is that? I'll print. It is actually a dictionary. So I have to take one more bracket. So this is this squares is here some spelling mistakes. SQRs. Do this again. So now it is printing the dictionary and it says it is dictionary. And as we already discussed, even the flower brackets are used to create a set. But if I take empty set, it is empty flower brackets, then as I told you, it is a dictionary, not set. Already we have checked it when we learn about sets. It's a dictionary. So empty flower brackets, if you use, it is a dictionary. So this is how we create. Now, once I create this, I can get the value for the key. So I can say print. If I want to get the value for the key, take the dictionary and give the value. So I want square of 2. So I'll get 4. I want square of 5 because the up to 5 we have. So I'll get 25. So if I want to get a value from, if I want to get value from key, so what you have to take is take the dictionary name, within square bracket you give key, then you'll get a value. You'll get value. So when only when key is present, you'll get a value. So suppose here, if I take this dictionary, now if I write one more duplicate key, suppose if I say 2, 10, suppose by mistake if I have written 2, 10 there, or instead of 636, I'll write 236. Now what it does is, because the key is repeated, the latest key value it takes, not the old one. So it has accepted. Now if you print this, see, you can see 236, not 24, because 236, 2 is key. Here also 2 is key. Duplicate keys are not allowed. When same key is repeated, the last key value pair is taken. So the last key value pair means in 2:4 and 2:36, 2:36 is appearing last. So I'm getting 2:36, not the 2:4. So that is how the duplicate keys are not allowed. Suppose if I take duplicate value is allowed. There is no problem. So I'll take again. I'll take the dictionary. I'll take some 6 and I'll say 1. So now it is not a problem because value is duplicate. So duplicate values it allows. So it is allowing 6:1. Here value is 1, value can be duplicate, but not the key. And so when I create a dictionary, I'll be taking key value pair like this. I'll be taking key value pair like this. So that key value pair I can represent. If I want later, if I want to add new key value pair to the existing dictionary, take name. So if I print this, I'll get the corresponding value. If I say equals to value, new key value pair is added. So here, I'll take this dictionary. So I'll remove this. This is not required. This is not correct. So I'll remove this because it is having not matching key value pair. So I'm getting key value pairs here, all valid. Now what I want to do is I want to add one more key value pair. Now I can say DSQRS, take the key, suppose 6 I want to add, assign the value. So now it is added. This is added. So I can keep on add any number. So if I print now DSQRs, new key value pair is added. New key value pair is added. So I can add a new key value pair to the existing dictionary by taking the name of the dictionary within square brackets. This syntax I have to use. If I want to add new key value pair, I have to use this syntax. This is the syntax I have to use. Now, one more thing is when I one more thing is when I try to get a value for key. So if I say print DSQRS, suppose if I take 4, it will give me 16 because it gets the value for the key. Now suppose if I give the key which is not present, it gives error. So it is giving error. So key error, it is saying 7 is not there. Now the other way of getting value for key, the other way of getting value for key is, okay, I can use get method. So the other way of getting value, this is one way of getting value. So getting value for a given key is, first method is use the name, dictionary name within square brackets key. This is first way, but more better way and more efficient is this one. Why it is efficient, you will know. So you can say dictionary name get key. Get key. So when I write like this, this also will give me the key value for the key. So I can say print DSQRS. Suppose 3. So it will give me the value for key 3. Now suppose if I give the key which is not present. Now this what it gives, it also it says none. Now so it is not giving error. Or if I want to make it more efficient, so I can give a message like not present. So if I say 7, it says not present. Suppose if I give 6, it is present, it will give the value. So here, when I give the this kind of thing, if I give the key which is not present, it gives error. But here I can give some message. So I can give some message not present or unknown, some kind of message for that. So what this get does is get the key value for this key if present. If not present, give me the result unknown. So 6, it is present, it gives 36. Now, when I give something like 10, it is not present, so it says unknown. Square for 10 is unknown because it is not there in the dictionary. So this is one more point related with dictionary. So we can use get or unknown. Then we can also, when I say the SQRS, we can get all keys. So if I want all keys as a list, we can get all keys as a list. When I take dictionary to get all keys as list. So I can say dictionary name of the dictionary dot keys. So similarly, if I want all values, I can say values. Now all key value pairs as list of tuples, I can say items. So you can observe each one. So I'll say print DSQRS keys. Now I'll get all keys, whatever present. So how we are getting as a list. So you can observe this is a list. Key value pair keys, all keys I'm getting as a list. Similarly, when I say print dictionary name values, so all values as a list. So as all values I'm getting as a list. Now I want dictionary, all the key value pairs in the dictionary as list of tuples. So I can say items. So see here you can take the list of key value pairs. Key value pairs I'm getting as list of tuples. So every pair is represented with a tuple because it is parenthesis, and the list of the tuples are kept in the list. Now, once I have this kind of thing, so what I can do is I can run through the dictionary with the help of a loop. So I can say for every value in keys DSQRS dot keys, I want the corresponding value. So I can say print DSQRS within brackets key value. So here I'll take key. I'll take key here. As it is more suitable word. So now for every key, I'll get the corresponding square. So I'll get the squares. So I'll get all squares. So that is how we can deal with keys. Dictionaries will further